Give me. That's from my mom. All right. If you would look at the board for me, I am going to try the same trick for today's lesson, which is on expected value and probability distribution. I'm going to use the same tactic that I use for conditional probability. I'm going to teach you the whole lesson with one problem. And it's a problem about something that's so real, you might mess around and pay attention to it and learn something. You there?
Mm-hmm.
All right. Now, Isaac, the Copeland one, if you would, when I give you the signal, there's a little bit more at the bottom of that page that we're going to need to see. But we're okay now with it right there where it is. Can everybody read what's on that screen? People out there in TV land, can you read what's on your screen? If you can read that screen, I think we're good to go. Can everybody read what's on the screen? All right. We're going to have a raffle. Now, a raffle is an inelegant word that describes a lottery. A lottery is a game of chance. Many will enter, but only a few will win. You get the premise of a raffle/lottery. You may be familiar with lotteries in your real life. I don't want to convince you to play the lottery or not play the lottery. I'm simply going to analyze the lottery and let you make your own decision. Fair enough? All right. So in my lottery, my raffle, I'm going to sell 1,000 tickets for $1 a piece. And I'm going to give one prize, a prize of $500. Now, our job in this lesson is to analyze the expected value, that is the predicted value that you will gain from participating in this lottery. Now, do you agree with me that somebody's going to win? Do you agree with me that most people are going to lose?
Mm-hmm.
Do you agree with me that the winner of the lottery is not the real winner? You don't have to agree with that now. I'm going to prove that to you. You ready? All right. So I've got 1,000 tickets sold for $1 a piece. How much money am I going to collect? I'm collecting $1,000. Remember, the prize is $500. Now let's talk probability. How many tickets are being sold? How many winners am I going to have?
One.
What is the probability of winning the lottery? 1 out of 1,000. What is the probability of losing the lottery? 999 out of 1,000. It's almost guaranteed that you're going to lose this lottery. If we're talking probability and numbers, right? It's almost guaranteed that you're going to lose. Here's how you compute expected value. There are two values to pay attention to here. One value is 500. That's how much you win if you win the lottery. The other value to pay attention to is -1. What does that represent? Well, that represents you having to pay $1 to engage this lottery opportunity. You with me on those values? Now, here's the math part. Listen to me now. Expected value is the sum of all possible values times their probability. What are our possible values? Our possible values are 500, and what's the other possible value? What's the other possible value? You know I'm just asking you that as a checkup from the neck up, right? Did you hear what I just said? There are two values. You win $500 if you are the lottery winner. You lose $1 if you're the lottery loser. There's a value of -1 assigned to all the lottery losers. There's a value of 500 assigned to the winner. The expected value is the sum of all the possible values times their probability. You there? What are our possible values? 500 and negative 1. What is the probability of me having that value of 500 put in my pocket? What's the probability of me getting 500? I can't hear you. What the probability of me getting 500 is 1 out of 1,000. Now, what's the product of 500 and the probability 1 out of 1,000? What's that product? Read it from the board. It's on the board. What is the product of 500 and 1 divided by 1,000? Why is there stunned silence in this room? Because I'm asking you to read a number. I'm asking you to read a number. It's 50 cents. 50 cents is the expected value for the winner. Because the winner is going to get $500. The probability of winning is 1 out of 1,000. Now, what is the expected loss for the losers? What should the losers expect to lose? What is the probability of losing? What is the probability of losing? Listen to what I'm asking you. The probability of me losing is 999 out of 1,000. What do I lose? I lose negative $1. What is the product of negative 1 and 999 out of 1,000?
99 cents.
You're going to lose 99 cents. So the total expected value is the sum of the expected gain and the expected loss. What is the sum of 50 cents minus almost $1, minus 99 cents?
49 cents.
It's negative 49 cents, right? Expected values that are negative suggest, yo, you're losing money if you do this at all. A positive expected value says, hey, maybe you should try this. It might work out. Is that a fair interpretation? That expected value is negative. You're being told, man, you might not want to try this one. If the expected value is positive, you might want to get in that. What do you think the expected value of winning most public lotteries are? Do you think it's a negative number or a positive number? It's probably a negative number. It's probably a negative number. I'm only saying that for the benefit of the people on the tape. It's probably negative. I'm pretty sure it's negative. Pretty sure it's negative. Isaac, would you scroll down a little bit for me? Just about right there. Scroll back up a little bit. Scroll back up a little bit. Stop right there. There we go. So people in TV land are seeing the same thing that you're seeing here live. All right, I'm looking right there where it says think twice. Now we talked about your expected value and calculated it as negative 50 cents. I'm saying that wrong. It's 50 cents. Now what is the raffle organizer's expected value? The raffle organizer is selling 1,000 tickets at $1 a piece. That's what he takes in. How much is he going to take in? What's 1,000 times $1? It's $1,000. Then he's paying out $500. So how much does the raffle organizer put in their pocket? Now what's the only thing that might diminish the raffle organizer's expected value? Well, you got to sell all the tickets, right? All right. But now, do you think they're going to sell all the tickets?
No.
All right, I think they are. You know why I think they are? Because people don't understand math and people don't understand expected value. So if you have a chance to win $500 by giving up $1, you're going to do it. Why do I know you're going to do it? I've seen it happen too many times to think anything else is going to happen. If I have a lottery in here, right, and I plan to very soon for educational purposes. If I have a lottery in this classroom, if you walk in and I say, hey, look, I'm selling 200 chances to win $20. And all it costs you is 1/4. All right? Do some math with me. If I'm selling chances for 1/4 and I'm going to sell 200 chances, how much money am I about to pull in?
$50.
I'm pulling in $50. I'm going to give a prize of $20. I'm pulling in 50. I'm giving out 20. I've won before announcing the winner. How much did I win?
$30.
I won $30 cold. How much is the winner going to win?
20.
Who's the real winner?
You.
Now, don't get mad at me. I understand math. I also understand human behavior. That even after I tell you I'm about to take advantage of you, how many of you are going to stand 10 toes down and say, I ain't giving you nothing? We'll see, because we're going to do it, right? I'm going to let a couple of days pass, then you walk in. I'm going to take advantage of how you don't remember what we do in here from one day to the next. I'm going to be like, boom, 1/4. You can buy as many chances as you want, but I cannot sell more than 200 chances in total, right? So if you say, man, you know what? I'm going to buy all of them. Here's $50. What have you won? You, my friend, I just probably won't go into business with you, right? Because you just guaranteed. Well, anyway, do you see how that works, though? Can you see how that kind of takes advantage of people every day? Even people like me. When I cross the state line and I go into South Carolina on my way to Virginia, I always stop at a gas station in Clemson, South Carolina, which is where I went to school. And I always buy lottery tickets. Mariah, you know why? Because I actually won some money there once. So I said, well, man, if I won once, I probably won again one day. Now I know, right? Because I know this problem. I know the chances of me winning are very slim, right? But I won one time, so I might as well try, right? And I actually won enough money to buy my gas at the gas station. So I'll try again. Yeah. So ain't nothing wrong with playing the lottery, but here's the decision that you have to make. How much of your money are you willing to throw away to perhaps have the opportunity to have so much money that everybody in your family will probably come and try to live with you or otherwise get you to give them money? Don't answer that. But do you see what I'm saying there? All right, so that's how we're going to teach expected value. Now, in summary, I compute expected value by first looking at my universe and seeing how many different values are in my universe. In the lottery universe, where there's a prize of $500 and a cost of $1, that means the only two values in the universe are 500 and -1. Then I got to look at the probability of the occurrence of each of these values. The expected value is the sum of each value times its probability. And that's easier done than said. Yeah. So the problems that Carmela is going to pass out right now will afford you the opportunity to apply that principle, right? Write it down, all that good stuff. And then I will let TV land go.